Hey, what's going on, guys? Let's do this problem right here. The question is asking for the circuit shown in the figure. The switch is initially open and the capacitor is uncharged. The switch is then closed at time t is equal to 0. How many seconds after closing the switch will the energy stored in the capacitor will be equal to 50.2 microjoule, right? So to calculate the time, we have to use this equation. Q is equal to Q naught times 1 minus e power minus t over time constant, right? So this is the equation we have to use. Let's see whether we have all the values. So first of all, we have to need the Q naught, that is maximum charge of the capacitor. It's not provided, right? So we have to find that one. And Q also we have to find that one. And then time constant also we have to find. Let's do this one by one. So the given information here is capacitance, that is 90 microfarad, and then energy is provided 50.2 millijoule, 2 millijoule, and then we have the voltage, that is 40 volt, right? 40 volt. And let's see how we can figure this one out one by one. So first of all, from this information, we have the resistance, right? That is 0.5 mega ohm, right? So from this information, we can first calculate the time constant. So time constant, let's say this rho is equal to R times C. So that's the equation for time constant. R is 0.5 mega ohm, 0.5 mega ohm, that is 10 to the power of minus plus 6 ohm, times C is capacitance, that is 90 microfarad. 90 times 10 to the power minus 6 farad, and plus 6 minus 6 cancels, and if you calculate this one, this is going to be 45 seconds, right? So 45 seconds is 45, right? So this is going to be 45 seconds. So we have this information right now, this one. So this one is found. Let's see what we can find next. So to find the maximum charge on the capacitor, we can use this equation. Q is equal to CV. So Q naught is going to be the maximum capacitor, maximum charge. CV, C we already know, 90 microfarad, times V, that is 40 volt. And if you calculate this one, that's going to be 9 times 4 is 3600. So we can say this is okay, so 3600 times 10 to the power of minus 6 coulomb. You can say 3600 microcoulomb or 0.0036 coulomb. Both of them are same thing. Now let's go ahead and see. So we have this information right now. Now only thing we need to know is this Q right here. To find this charge, what we can do, we have the energy provided 52 millijoule, and we know the energy equation. U is equal to Q square divided by 2C, right? This is derived from half QV, that is same as V is equal to Q is equal to CV, V is equal to Q over C. So we just plug the Q over C instead of this V. That's going to give us half Q square divided by C. So that's how this equation derived. And let's plug the values. So we are trying to find Q right here. So Q square is equal to 2UC. Therefore Q is equal to square root of 2UC. So this is going to be 2 times the energy, that is 50.2 millijoule. Milli means 10 to the power minus 3 joule, times capacitance, that is 90 microfarad. 90 times 10 to the power minus 6 farad, and if you calculate this one, that's going to give us a charge. and that gives us 3 times 10 to the power of minus 3 coulomb. This is same as 0.003 coulomb, right? Now let's see how we can find the time. So now we have all the information. Let's plug it in this equation, but before I do that, let's rearrange this one first. So we are trying to find this t. So t, so the question is how many seconds, so time is the question, right? So let's rearrange this one. 1 minus e power minus t over time constant is equal to q over q naught. Now let's get rid of this bracket, and I can bring this 1 to other side, so this is going to be minus e power minus t divided by time constant is going to be equal to q over q naught minus 1, right? Now to get rid of this e power e, we can take ln both sides. So whenever you have ln and e, it cancels each other. So here we are just going to have minus t by c, and other side we are going to have ln q. So you can write, one can be written as q naught over q naught because we are taking q naught common denominator. So this is going to be q minus q naught over q naught, right? And so if you calculate, let's say, so here we are going to have time over time constant. We can also bring the time constant to the other side, but before I do that, I simplify this one. So this is going to be t over time constant minus minus plus, and here we have ln q minus q naught. Actually we don't need this one, right? Because the answer is going to be negative and you will get positive answer, because yeah, you will get a positive answer. You're supposed to get a positive answer, right? And q minus q naught, and then we have q naught in the bottom. And also this time constant is unnecessary, we can move it to other side. So this is going to be t times time constant ln q minus q naught over q naught. And if you now let's go ahead and plug the values. We have this time constant, that's 45 seconds, ln q minus q naught, that's going to be q is 0.03 minus q naught is provided 0.0036 divided by, so we have, what else we have, q naught in the denominator. So q naught is 0.003, right? 36 is q naught, and if you calculate this value, that's going to give you 80.63 seconds. That's approximately 81 seconds. So this is how much time it will take, right? The question says how many seconds after closing the switch will the energy stored in the capacitor will be equal to 50.2 millijoule. This is how much time it takes, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.